Okay, so we have already discussed first four properties of conductors in electrostatics. Now moving forward, we have two more properties which are very important considering the numerical part of this chapter. So we will discuss first the two properties, and then on the basis of those properties we have some derivations also. So property number 5. This property says that electric field on the surface of a charged conductor is equal to sigma by epsilon naught, where sigma is surface charge density. So suppose this is a plate and on this side there is a positive charge of charge density sigma, and now we have a cylinder, an imaginary cylinder here. So inside a metal, electric field is 0. So since here the electric field is 0, the flux here will be 0. From lateral surface area there will be no flux because electric field is perpendicular to the surface, and flux will only be through this area, circular area A. So from this area the flux will be EA cos theta, theta is 0, so cos 0 will be 1, so flux will be EA. Now net flux is basically charge enclosed divided by epsilon naught. So net flux is EA plus 0 plus 0. Total charge enclosed is sigma A, because sigma is Q by A. Sigma is surface charge density, it is charge upon area. So Q will be equal to sigma A, putting the values and cancelling A on both the sides. So electric field is basically sigma by epsilon naught. So if the plate is positively charged, electric field will be outside, and if the plate is negatively charged, electric field will be towards the plate. So this is a very important derivation for electric field due to a metal plate or a metal sphere. So basically electric field is equal to surface charge density divided by epsilon naught. This formula is only applicable for conducting surfaces. The property number 6 says that electric field inside a cavity in a charged conductor is 0. This property is also known as electrostatics shielding. Suppose we have a conductor and there is a small cavity inside this conductor. The conductor is charged. So now we know that if we put any charge on a conductor, the charge will move to the surface of conductor. So inside there are no charges, so electric field will be equal to 0, and if electric field is 0 then potential is constant. So value of potential will be same at all the points inside this conductor. Even in this cavity also the value of potential will be V, and electric field inside this cavity will be equal to 0. The reason being since E is equal to minus dV by dr, but since potential is constant because at all the points value of potential is same, so electric field inside the cavity will be equal to 0. So you have to remember this definition of electrostatic shielding, because since there are no excess charges inside this conductor, so there can be no electric field. So electric field inside this cavity will be equal to 0. But suppose if there is a charge inside cavity, then this property is not applicable. This property is only applicable if the cavity contains no charges. Okay, now suppose that a charge Q is given to a conducting plate of area A. So what will be the surface charge density on both the sides and also electric field near and inside plate? Now this is a conducting plate and a charge Q is given to this plate. So charge will distribute itself. So Q by 2 will come on this side and Q by 2 will come on this side. In between the plate, since inside a metal electric field is 0, so inside the value of electric field will be 0. But on right hand side and left hand side of this plate, since the charge here is Q by 2, so sigma will be charge by area, that is Q by 2a, and electric field is basically sigma by epsilon naught. We have just derived the formula of electric field to be equal to, we have just derived that electric field is basically sigma by epsilon naught. So using this formula, electric field will be Q by 2a epsilon naught, because sigma is Q by 2a. Similarly, on left hand side of this plate, electric field will be same, that is Q upon 2a epsilon naught. So for a metal plate, always remember if you put a charge on a metal plate, the charge will distribute itself. so that the electric field inside the plate can be 0. So at any point in the plate, inside this plate, electric field at all these points will be equal to 0. Now we have some more numericals related to this property. Suppose a charge Q is placed at the center of two conducting spherical shells. Find charge on each surface and also electric field in all the areas. So a charge Q is placed at the center of this spherical shell. So due to charging by induction, since both the shells are conductors, so here we can use charging by induction. So this charge will attract the negative charge on the inner side of the smaller shell. So now this Q will attract minus Q on the inner side of the smaller spherical shell. Now Q will attract minus Q and it will repel positive charge. So on the outer side of the shell there will be plus Q. So on the outer side of the shell there is plus Q. So Q will induce minus Q on this side and will repel plus Q on the outer side of the shell. Similarly, now this positive charge will attract negative on the inner side of the bigger spherical shell like this. So this Q will induce minus Q, will repel plus Q. This plus Q will attract minus Q, and if you think this Q will repel positive charge that will come on the outer side of this bigger spherical shell like this. So this is how the charges will redistribute themselves. So there is a Q, it will induce minus Q, repel plus Q. This plus Q will induce minus Q and again repel this plus Q. So this is how the charges will redistribute themselves. Now this is about find charge on each surface. Now we'll come to the next topic, that is electric field in all the areas. So suppose we have to find electric field at this point at a distance r from the center. So at this point there will be electric field only due to the charge at center, that is kq by r square. Because if you will refer to our last lectures, then inside a charged shell electric field is 0. If you remember this from Gauss theorem, inside a charged shell, if a shell contains a charge q and radius r, the electric field inside at all the point is 0. So this point is inside of all the spheres. So at this point there will be only one electric field, that is kq by r square. Now at this point, see, this point is inside the metal. This point is inside the metal. So electric field at this point will be equal to 0 because this point becomes part of this metallic shell. So the electric field at this point will be equal to 0. Now coming to this point. Now at this point there will be 3 electric field due to this Q, due to this minus Q, and due to this plus Q. Now electric field due to Q and minus Q will cancel out. So we'll only remain with the electric field due to this plus Q. So due to this plus Q, the electric field will be kq by r square. Because if a point is outside a metallic shell, then the distance is to be taken from center of the shell. So this plus Q has center as this point, and this point is at a distance r from the center. So electric field will be kq by r square. Again, at this point inside the shell, electric field will be equal to 0 because inside a metal, value of electric field is always 0. Now your homework is to find electric field, suppose at this point. Suppose I ask you to find electric field at this point, so you have to find out electric field at this point. Now with this video there is an online quiz in the description below. Also the quiz will be with the message of this video. You have to submit that online quiz. Okay, if you have any doubts, you can WhatsApp me, or you can ask me in my WhatsApp message also. Okay, so go through this question again, and if you have any doubt regarding how to find electric field, please let me know. Okay.